Hey everybody, how's it going? So today we've got an ancient old A1278 MacBook that's not powering on. Let's open this thing up and see if we could figure out what's wrong with it. Oh my god. You're an 820-2879. Core 2 Duo with an MCP89. Jesus, this thing is old. By the way, if you can't see the 820-2879, you might just have some problems with your vision. See? It's right over here. See that? 820-2879. Clear as day. You should be able to read that very easily. If you're having problems with that, you might just have problems of being in this business. See that? 820-2879. There's no green light on the charger. So let's see what happens if we try to turn it on manually using the power pads. It doesn't look like we get anything. Alright, so let's check out the one-wire circuit on this. Now this is supposed to be 3.3 volts, 3.42 volts on that chip over there. That's 5400 RPM, pseudo beeps. 5400 RPM. Alright, see that? PP3V42 is not present where it needs to be. Alright, let's remove the board from the case. This has a nice, pretty, simple little one-wire circuit. So for the one-wire circuit to work, I need PP3V42_G3hot to be present. PP3V42_G3hot is created by U6990. U6990 is going to be right over here. So let's just check out this one-wire circuit. Isn't this beautiful? You have your DC power jack over here. It has 3 lines. 18 volts, 18 volts, ground, adapter sense. Adapter sense is going to go to this chip. Now this chip serves as a bodyguard to the system management controller, which is what talks to the charger on the sys one-wire line. If you are drunk and you plug this magnetic connector in sideways so that 18 volts goes to adapter sense, this says, oh hell no, I'm not letting 18 volts into the SMC, GTFO. But if it's the 3 volt data line, then it lets it speak to the SMC. This chip is powered by this chip. And this chip is powered by PP3V42_G3hot. If SMC BCACOK is present on pins A and B over here, it sends PP3V42_G3hot over to this chip, which allows the adapter sense line on the charger to communicate with the SMC, which allows it all to turn on. But in order for that to work, you need PP3V42_G3hot, which is why we're going to take a look at the U6990 circuit and see what's going on with this board. Now, in order for that to work, you need voltage on pin 6 for it to turn on. Right over there. That's going to be the power from the charger. So let's see on the board what happens if we measure over there. Okay, so I have 0 volts there, which means nothing's going through. Alright, so let's follow that back. R6905 is back here. Let's see what we have on each side of R6905. Zero. 17. Huh. 0. 17. 0. Okay, you get the idea what's going on here. Now, I'm not going to replace that resistor without trying to figure out why it failed first. The first thing I'm going to do is see if there's a short to ground after it. And 90 ohms? That's not right, ma'am. That's not right. So there is most likely a short to ground somewhere here. So let's go back to our schematic and board view. Now, where could this possibly be short? You have 2 possibilities. It could be only 2 things, right? You have either A, U6990, or B, this capacitor to ground. It's the only 2 ways that this thing could be short to ground. The only 2 ways. Now, there could be technically a short on output of PP3V42, but that is, yeah, that's not even remotely there. It's open line. Also, by the way, look at this. They can't even draw their lines right. So instead of having this line in the schematic, one 18 volt going to voltage in, the other going to the shutdown pin, they're both going to the shutdown pin and voltage in is just going nowhere. They couldn't just make the line go from here to here. And this is really important. And the reason I'm pointing this out is, if they can't even proofread the schematic diagram that says how the machine is built, how the fuck can you trust that they're actually building a machine that's made to last? When I go over all the design flaws over the past 11, 12, 13 years of Apple products, and I talk about how their designs are unfit, I just want you to think about this, that the final documentation that says how this product is put together is actually wrong. In the last video that I did, I was talking about how they can't even get right the voltage that goes to their RAM. Is it 0.35 volts or 0.675 volts for DDR-VTT? Do they use an ISL6258, an ISL6259, or an ISL9239? And here, they can't even get the lines that show how things are drawn together properly. I just want you to think about that, because this product, when it came out, was priced as a premium product. You have to remember, the A1278 MacBook, all the way in late 2015, they were selling a dual-core Ivory Bridge machine with about 4 gigs of RAM, 5,400 RPM spinning hard drive for $1,049. They can't even draw the lines right. I'm just saying. Anyway, so it looks like we have a short, and it's going to be either the cap or that. So C6999, C6990, or the chip. Now, I'm going to guess that it's the cap because that is corroded, whereas the chip looks kind of fine. So we're going to have to find ourselves a donor 820-2879, because I don't think my donor cap spin goes up to 805 in size. So we're just going to knock that cap off the board. We may not actually even need that cap. I'm just saying. So let's see what happens if we just knock that cap off the board, if we get anything funky happening. According to my monitor, it says that my iron is 840 degrees, but this is not acting like it's 840 degrees. Okay, there we go. I'm going to get some tip cleaner. It's always important to clean your tip. You gotta find something to clean your tip every now and then. If your girlfriend leaves and you don't know when she's coming back, helps to have something else to stick your tip into. Especially if it promises that it's going to clean your tip. Alright, there we go. So you don't want to dip your tip in too long, just, 10, 15 seconds. And then after the 10, 15 seconds in there, we're going to go over to the HAKKO 599B and clean it up. And then, if you're a real savage, while your girlfriend is watching and chat, you can stick the tip in. Oh, yeah. Oh, that is so satisfying. And when you're done sticking the tip in, every now and then it's good to smoke. For some people, once they're done sticking the tip in, they'll just allow it to smoke for a little bit right after they're done. Kind of relaxes them, See that? See the little bit of smoke? Just to help you relax. All right. Okay, have the multimeter in ohms mode. So we went from 90 ohms to ground on that area to now about 170,000 ohms to ground. So I'm going to say that the cap was the problem and not the chip. So we did guess properly. And that was a guess because it was one or the other. Now, I made the guess based on some information, and it's better to have a guess based on information than a guess just based on a guess. But that guess was based on the fact that the chip was not at all corroded, whereas the capacitor obviously was. Once we restore PP342_G3 hot on this machine, we should expect this beautiful Core 2 Duo masterpiece to return to functionality. So now I'm going to try to do this without a hot air station. So what I do, let's just say I didn't have a hot air station available to me. What you could do over there is you could just solder one pad rather than both pads. Then you take your iron, Core 2 Smooth Max are more stable than modern T2 chip Max for various real-time professional apps. Audio, less crashes, latency. You know, can you email me an article on that? I may not be able to respond to you exactly, but I just don't want to forget about looking into that. I'd be really interested to understand or gain an understanding of what it is, if anything, that makes a T2 chip MacBook more unstable or have more latency when it comes to real-time audio and video applications. Very curious. Thank you very much for taking the time. So we are going to replace our capacitor. And since water got over here, we're just going to give our chip a little bit of rehab. And put that cap back where it should be since I knocked it off. Wasn't very nice of me to knock that capacitor off. I'll just use the hot air. You have a legitimate gripe there, hello. Most of them will be, because I mean, even we have trouble finding those, actually. Especially A1417s. It's a bit of a nightmare for us right now. I've always wondered if New York pizza is really that good, says Margarita Doctor. No, pizza in general is crap. There are so many things to eat. There are millions of things that are better to eat than pizza. I don't even mean better for you. I mean better as in they just taste better, they are better. New York City pizza sucks. It's the kind of stuff where you pick it up and it just flops. It's like, bleh. And then people say, well, you have to fold it. You don't understand. You're using it wrong. They apple you when it comes to New York pizza. You're using it wrong. You need to fold it. Because I'm supposed to origami my food after I pay for it in order to be able to put it in my mouth. Great. But then when you fold it, it's so fucking oily that once you've folded it, instead of the oil staying here, it just starts to go out like a spigot onto your plate, and it never stops. It just keeps going and going and going. It's disgusting. I can't believe people eat that shit voluntarily. Disgusting! Let's replace the resistor. I got rid of the cause of the short, but I never replaced the resistor that blew. Alright. How do you have 49,000 subscribers here and 1.05 million in your other channel? Lopsided a little. I would argue with you that I don't have 1.05 million on my other channel. If I post a normal, like a board repair video, it usually gets about 20,000 views. If I post an interesting board repair video, maybe it'll get 30 or 40,000 views. If I post a video about an issue that I think is interesting or important, it'll get 40 to 50,000 views. If I post something that's crazy viral, then the crazy viral video will get 80 to 120,000 views. So I don't think I actually have 1 million subscribers. I don't know how YouTube rates that stuff. I don't know how that works, but that does not seem to be even remotely accurate. I would say that the number of subscribers I have on the live channel is actually closer to my real following. Okay, there we go. So again, one of the things I like to do is I try to show you what it would be like if I didn't have a hot air station. We wick the solder. We solder one side, and I use... Now remember, typically you're supposed to be adding solder as you have the soldering iron there. You don't just have the solder stay stagnant, or else you get crappy joints. But I need the tweezer to push it down, and this to solder with. So I add flux before I solder, and adding the flux before I solder makes sure that I get a nice pretty joint out of it, which is what we did there. So now we should have a happy little green light. Alright, we have 30 milliamps amp usage. My resistor is not smoking. Let's see if I get a fan spin. Do I get a fan spin? I probably don't get a fan spin because this board is from 2010. Yeah, you're not going to give me a fan spin, are you? So we're going to short the power on pads. No fan spin. And you're stuck at 24 milliamps. Oh, the sadness. Here we go. We have a green light now. Oh, fan spin! Okay, look at this board. Look at the amp usage. Damn. An A1502 takes 5 to 600 milliamps. The Air takes 5 to 600 milliamps. This thing takes a full amp. This thing takes almost as much as the 15-inch Retina booting out. The machine that has a dedicated graphics card that's powerful and a quad-core CPU takes about almost the same, like a little bit more amperage than this piece of shit takes to turn on. Wow. And the reason I have to do that is these don't turn on automatically. SMC on-off L pads actually have to be shorted in order for that to turn on, and I had to scrape them because they were so junky because they're so old that they weren't responding to my tweezer. But yeah, as you can see there, we have a green light, and it does turn on. So let's just go over the lesson here, because a similar circuit to this is still used in newer machines. Now, we were not getting a green light. There was no green light. And first thing you got to do to get the green light, take a look at your one-wire circuit. The one-wire circuit is going to be where you have adapter sense. That is the sense line from the charger. That's the kind of like the brain of the charger. This is where the charger plugs in, by the way. MagSafe DC power jack. That's going to speak to this chip. This chip is then going to allow the charger to speak to the system management controller, which needs to happen in order to get a green light. This chip is going to turn on if it has power at its VCC pin, typically the pin at the top, or anything where you see VCC, VDD, VIN, that's voltage in. That needs to have 3.42 volts. That's going to come from this chip, and this chip's going to get that from PP342. So that rail has to be present. This rail wasn't present. I looked at voltage in. That wasn't present. So I went back over to here. This was not present. Then I went back over to here, and I had 17 volts, but I had 0 volts here. But I had 17 volts there and 0 volts here. So what I did was I checked to see if there's a short circuit over here. I did, and I saw there was 92 ohms. It was either the cap or this that was going to be shorted to ground. The capacitor was corroded. The chip wasn't. So I replaced the capacitor, and the short was gone. Then I replaced the resistor because the short was no longer there, and it worked. Had I simply replaced the broken resistor and left that capacitor there, which is what many people do when a fuse blows, let's just replace the fuse, just reset the circuit breaker without figuring out why it blew, it would have smoked and blew again. But it didn't blow again, as you can see. we have a fan spin, and we have a green light. So that is fixed. Well, that's it for today. Thank you so much for watching, viewing, taking part in everything we do. Hopefully you learned something that you can use to revive one of these old machines. I am kidding as much as I like to just bash on it because it's an MCP89 machine and I have a personal vendetta with these for the frequency at which the MCP89 would just die. I am, it's good to make it work again because as we can say what we want, but there's people out there that probably couldn't afford a better computer than what you have over here, and it's better that it worked than it doesn't. Regardless of how slow this is, this has more value in a working machine than it does in a dumpster. And companies like Apple would prefer that when something like this happens, that this wind up in e-waste, that this little robot Liam take it apart and just recycle it to nothing. But I think what would be better is if people like you watching use these videos, learn from them, really understand what's going on, and then take stuff like this and make it work again so that you can make it available to people who couldn't otherwise afford it. That's it for today, and as always, I hope you learned something.